Jorge Ramon and Ramon Colon, and our project is we're Team MR2 1.2, and it's a Mars rock retrieval. And what we did was we designed our robot for the ASME student competition in University of Alabama. So we built it to those specifications. Now this is our basic outline and how we tackled this problem. You know, all the different between programming, assembling, and the guidelines that we had to follow according to the ASME standards. And now NASA's statement right now is they want to, for future moon missions and Mars missions, they want a rock retrieval vehicle, be it autonomous, remote controlled, radio controlled. Now they want different scenarios. They either want it to be you to work with it from, let's say, a station like the ISS on site, like physically at the site, or even from Earth. They want to do it, and they're just testing out different things. And this is just a rough estimate of how we could try to accomplish those different goals. And these are the regulations provided by ASME. The size limitations is 14.5 inches long, 6.5 inches wide, and 6.5 inches high. Now all of that has to fit in that volume, be it the controls, the rover. Now you could try to bend it. You could come up with different designs that you could maybe make it fit in the box and adjust to it. And it must climb a height of 4 inches. The chassis cannot be machined, and the batteries have to be over-the-counter rechargeable batteries. And Jorge is going to talk about the structure designs.
Okay, let's talk about a little bit about the structural design. Basically, we had to follow the directions that he was saying, all the dimensions. So the best way we came out following all of that, we figured out that by joining two bobbins, like the ones you could see here, and then we used the same rubber wheel that you see in the middle to attach them. And then we had is that we had to come up with wheels that would allow us to go over 4 inches, a 4x4 inches wood log. So that was our first struggle. The first design that we had, which is this one that you could see here, MR2 1.1, we actually put some wheels that were machined by us. They were made out of plexiglass, and they look very nice. But the only problem is that they weigh a lot, so it was hard to be able to go over the 4x4 goal. So what we had to do with an inexpensive solution, which it was using jar lids, and attach them to the regular which are these little black ones here, and that allows to be able to fit it in the regular servos. The other thing that we added a gripper in the front, as you can see here. That gripper would take care of picking up the rocks that we had to accomplish as part of the mission. That's for that gripper. You can see here, this is the servo that is taking care of that. And then here you could see a picture of the final product, which is MR2, we call it 1.2 because it's like the second version that we did, which is this one that you can see here, and over here you can see retrieving a rock. Next. Actually, skip.
All right. Well, I'm gonna talk about the circuit. The way that we did it was that we found the chip for the PlayStation controller. The chip, we knew exactly what was sending the signal out and what was receiving. So in order for us to be able to communicate the PlayStation controller with the BS2 chip, we need a resistor, which inverted the signal, because the PlayStation controllers are not meant to be used for the BS2 controller. So you will have, this one is the big layout of the connection of the PlayStation only. This one is actually the complete layout of the whole circuit. This one is the BS2 chip, which goes from pin 15 to pin 12. It goes to the different servos, 15 and 14, 12 and 13, and then it goes through 11, 10, 9, and 8 for the PlayStation controller. This is our PlayStation controller. And they are denoted by color, but actually when you go into the data sheet, they actually tell you what is in and what is out, which I did over here. As far as the programming, what we did, we use a base code that is meant to check the signal, where the controller is sending a signal, where or not the VS2 chip is receiving a signal. So what we did, we used that as base, and the only thing we erased from that base was the values that it is. When it gives a debug terminator, it actually gives you the values of whenever you pass the binary numbers and the decimal numbers of that value for that button. So what we did, we changed it to hexagon, and then we erased that once we know the values. And when we did that, what we did, we went ahead and implemented the gripper code and the wheel servos. That we were able to know what was the actual hexagon value, and with that we were able to actually control the bubble completely using a PlayStation controller. For future work, we need to do several stuff. As part of the regulations for the ASME was that we had a multi-pin connection, which in our case we got disqualified at the competition because we didn't have a multi-pin connection. What we had was a straight connection from the cables into our breadboard. Another thing that we want to improve is that our code only works for a Type H PS2 controller. We would like to see if there's any way to use any random. That way you don't have to be looking in the game store's PlayStation controller. That is this is our reference, and go ahead. These are the people that aportó. I'm sorry, that contributed to our project. The only one person missing here is the Focasia cafeteria from FIU, which was the one who gave us the leads for the board. And got a video from the board working, because when we were at the conference, the box that Marco was talking about, we were supposed to go ahead and fit it, and I got a little nervous because it was jamming, and when I jam it, I messed up the circuit. So right now, it doesn't really do nothing. That's for working on its own.
It should be moving on command for the PlayStation, for the controller. The analogs, when you push it up, it goes up. You move it back, it's supposed to go back. There's a slight demonstration. You can turn left or right. Now here, since it's on tile, what we're testing right now, the acrylic wheels, the plexiglass wheels, which were a little too big. And on the tile, it would actually slip a lot. And at the competition, so it provided a little more friction, so actually a little easier to move. And to manipulate, we used the triangle and the circle on the controller. Triangle was to open it, and circle was to close it. And as you can see over here, the gripper originally came as just basically hands. And now we wanted to add maybe like a shovel type of gripper. So we put these little aluminum plates here, so when it would close, it would kind of scoop it up and the rock would stay in place. He's testing it out. He's basically telling me to put the rod out to see if it works. Do we have another video?
Yes, we do.
Give it a second, so.
Okay. And this concludes our presentation. We'll give another demonstration.
Okay.
Take over.
The reason why we decided to attach two balls by the rear was because we needed this angle. When the bubble goes up in a certain way, it tilts a little back, but once it reaches the top of the obstacle, it actually needs to bend. If it wasn't for this angle right here, well, what happened, it would just stay like this, and then the gripper wouldn't let you actually have that bend, and you wouldn't be able to pull. So with this one will pull, and this one will keep pushing, and then it will just go over. So that's the reason why we had it like that. Are we ready for the video?
Yeah.
Yes. All right. Go ahead and run it. You want to talk about the video?
All right. Yeah. I'm gonna talk about it.
On this video, this is from MR2 1.1. This is the first one that we show you, that you could see it has the small wheels, the regular wheels that come with the bubble, but you could definitely see there that it's already moving. The only thing that it was not integrated was the actual gripper.